Okay, so this lab, one of the longer titles, is spontaneous celebration of recreation. So, the reason that I wrote this lab is so you get an idea of what these reactions look like. So you can go through all the math, say, oh, is it endothermic or exothermic, is spontaneous, is it not spontaneous. So all this lab does is allow you to see what these reactions actually look like, okay? And you can measure the temperature and you can get an idea of the entropy. Now, here's the downfall of this in terms of being able to do actual measurements. Again, you don't have Gibbs free energy probes, we don't have enthalpy probes, we don't have entropy probes. We don't have them. What we can do is, for example, on entropy, we can make observations. You know, okay, great. So the first reaction that we're going to do together as a class is a reaction between hydrochloric acid and sodium bicarbonate, otherwise known as baking soda. Okay? So one of the gases that you're going to get out of this is carbon dioxide. Okay? So you're going to take a concentrated hydrochloric acid, and we're going to add to that sodium bicarbonate. And you're going to get all this carbon dioxide produced out of this reaction. Okay? So over here on page 2, up at the top, I've got the reaction listed out. You have hydrochloric acid, sodium bicarbonate. And you're going to get aqueous salt, water, and carbon dioxide gas. So one of the things you can look at to determine just a basic idea, it's not always true, but a lot of times it is if you're producing a gas, especially if it's a complex gas like carbon dioxide, that's pretty big, it's a carbon and 2 oxygens attached to it. Then if you see an increase in the moles of gas, that tends to say, well, that's probably going to get a positive delta S, okay? Because of the fact that you're producing a gas out of this. It isn't always true, but a lot of times it is. So that's kind of a guiding light. When things dissolve, what tends to happen to your entropy?
Increases.
It increases because you're going from locked up into a solid structure into a situation where they can dissolve. So if you look at this, you have hydrochloric acid as a liquid. You're going to react that with a solid. You're going to get some ions, water, and a gas. So just by virtue of the fact that you're going to be producing, and when you see this reaction, we'll do this in just a second, you get copious amounts of carbon dioxide that's produced. You got to figure, okay, I'm probably going to get an increase in my entropy. Now, the reaction is going to take place. I'm not going to have to hook it up to, I'm not going to take a battery source in there, a power source. I'm just going to mix these together. So what's going to be the sign of your delta G?
Negative.
Negative. The reaction takes place. It was like, that was boring. What'd you do? Oh, we mixed sand and water together. Cool.
I have dirty water.
Yeah, now we have dirty water.
Delicious.
That was cool. Probably what's the sign of your delta G?
Negative. Zero.
Well, it's not going to react.
Nothing's gonna happen to zero.
Yeah, you put sand and water together. What reaction do you get?
Just dirty.
You get dirty water, okay?
Water with texture.
So, I'm just saying.
Water gets
Now, so what you're going to do, and pay attention to the spirit of how I wrote this lab. So, we're going to record try 1 observations, okay? We're going to predict what the sign of delta G is going to be, and we're going to give a justification. Let me give you a hint. Delta G should be a negative value, and then, wow, the reaction took place. Okay, cool. Delta S, okay, that's probably going to be a positive value because of the fact that we're going to see this copious amounts of carbon dioxide that's produced. Okay, cool. Initial temperature and final temperature, we're going to keep track of that based upon the change in temperature. Now remember, you're measuring the change in temperature of the surroundings. So, quick refresher. If, and this is a huge if the temperature of the surroundings goes up, what's going to be the sign of delta H for the system?
Negative.
Negative, because that's going to be in
Exothermic reaction.
exothermic reaction. If the temperature goes down, it's going to be in endothermic reaction, and delta H is going to be a positive value. Okay. So we're going to keep track of that temperature. So that one we're going to do together. Now, the nitrite and the iodide. So this one, you're going to mix about 4 milliliters. Notice that I just said 4 milliliters, okay? Notice I didn't say 4.000, okay? Get about 4 milliliters of your sodium nitrite and about 4 milliliters of your potassium iodide. And you can do that in a test tube, you can do it in a beaker, I don't care. If you're gonna do it in a beaker, just do it in like one of those like 50 milliliter beakers. But you're gonna mix them together. Initially, when you mix them together, nothing's going to happen, okay? The magic is going to happen.
Can you imagine throwing the iodine in our faces? You know that?
The magic is going to happen
Yeah,
when you add the sulfuric acid. Okay, you're going to add 3 moles sulfuric acid. So what do you think you're adding when you're adding sulfuric acid?
Hydrogen ions.
Hydrogen ions. Okay, so this is going to be an acidic environment which a reaction is going to take place. All you're doing is you're measuring the initial temperature. This is after you mix the iodine and the nitrite together. Measure that temperature. Then add the sulfuric acid and then measure the temperature. That's going to be a relatively small change in temperature.
Why are you looking at me?
You know exactly what I'm looking at.
I made eye contact with Grant. It's his fault.
On video forever.
God, you know why I don't teach freshmen?
Why?
They do stupid stuff like that.
It's just a class
I
full of
just
color.
made eye contact.
What else seniors do you have?
Just a class full of color.
Okay, that temperature change isn't going to be very dramatic, so pay attention to that. You want to record either the highest or lowest temperature that you're going to see. This one is going to be primarily based upon observations in terms of, hey, is there a gas produced? Is there not a gas produced? What's going to happen to the change in temperature? Magnesium and hydrochloric acid. Okay, you need to take, again, about 5 milliliters of 1 molar hydrochloric acid. Put it in a test tube, drop in a piece of magnesium about yay long. I'm going to have pieces of magnesium in there. This is more, hey, let's measure the temperature because we know what's going to happen. Sodium in the water, with that one, you're going to take about 50 milliliters of water in a beaker, bring it up, add some phenolphthalein. I'm going to drop in a piece of elemental sodium. We're going to measure the temperature before and after, okay? That's, the lab portion of this goes pretty fast. Now, when you get to the lab write-up portion of it,
Why are you laughing? Why are you laughing?
I don't like that a lot.
You're like rubbing your hands and
Like a little block.
Don't know how I feel about that.
okay,
It's too much work.
got shot. Get over it.
You don't
Now,
know.
This is so many pages.
Hey,
I know
I
the
know these are good grades.
lots of space. Now, so this is where this goes full cycle in terms of like the sum of the standard formations of enthalpy, entropy, or Gibbs free energy. So on 1C on page 2, there's 2 different ways that you can calculate delta G. One is that you use your delta H and you go through the back of the book, and you have to have that index in the back of the book. So when you're going to find a theoretical value of delta H, So remember, that's gonna be the sum of, it's always products minus the sum of the reactants. So you're gonna go through, and some people, because you're gonna be using like all three thermodynamic values, delta G, delta H, and delta S. Some people take like a piece of paper or an index card, and then that way they can work across, because sometimes the math isn't that difficult. Usually if this goes south, it's because you used the wrong number. So what you're gonna do, like on that first reaction with the hydrochloric acid and the sodium carbonate. So you're gonna go through and you're going to find, for example, on that sodium chloride, aqueous, you're gonna go through the book and you find, hey, it's aqueous sodium chloride. And you're going to look up the delta H value, so you're gonna have, the beauty of the NaCl, there's all of these coefficients in this particular reaction just have a value of 1. So you're gonna have your NaCl plus your H2O, now notice that's liquid water, plus your CO2 as a gas. So you're gonna add all of those delta H's together. And then you're gonna subtract the value for the reactants, okay? Now, sometimes the hydrochloric acid gets a little bit wonky. Sometimes you just might see that listed as Cl, and I don't remember how that's listed in this book. I'll make sure I'll figure that out and I'll write that on the board. And then your solid NaHCO3. So you're gonna add those together and you're gonna subtract them. So you're gonna get your delta H that way. Then you're gonna do the same thing with your entropies, okay? You go through, you're gonna find the products of your entropy values of your products, add those together, subtract the reactants, just like you've done before. Then you're gonna do the same thing with the Gibbs free energies. You're gonna go through, look up the three values for the Gibbs free energy, add those together, subtract the products. So the second way that you can do this is on F. The second way you can do this is that you use the delta H and the delta S from up above, and I tell you to use a temperature of 25 degrees. So on F, what you're basically going to do is you're going to compare the delta G values. One from using the sum of your delta G values, and the other one using delta H minus T delta S. But I tell you, because that's temperature dependent. So in that one, you're gonna use 25 degrees Celsius. The temperature is gonna vary quite a bit in this, I'm gonna say, but we're just gonna say, hey, under standard conditions, 25 degrees Celsius. But what are you gonna do with the 25 degrees Celsius?
Convert it to Kelvin.
Convert that into Kelvin. Now, when you get to page 3 on number 2, the first thing you have to do is balance that reaction. You have to balance it on two things: charge and number of particles. Okay? I'm just saying. And then you're going to do the same thing with that. Delta H, delta S, and delta G. And then you've got a bunch of questions to answer after all of that. So, let's get the lab done.
Technically, it would be wrong.
Yes, this lab is going to be due on tomorrow.
What?
Just telling you.
You think we're just made of time?
Yep.
This
What about
is due
physics?
tomorrow?
Hold up, what about
Yep.
physics?
That's not a horrible assignment.
Bird, bro. I know.
Alright, yeah, we gotta go.
Bring it.